Okay, now let's do part B. Okay, so we want to prove that this V is infinite dimensional. Okay, for this question, I will do proof by contradiction. Okay, why? I think it is easier to do this question by proof by contradiction. Okay, I hope you still remember what is proof by contradiction. So I try to say that this is not true. Okay, try to say that this is not true. Okay, and I want to find a contradiction. Okay, so proof. Okay, proof. Okay, so suppose that V is finite dimensional. Okay, suppose that V is finite dimensional. Okay, then what will happen? What does it mean by finite dimensional? It means that this means if B is a basis of V, okay, then there are finitely many vectors. In this case, the vectors are just the functions. Finitely many vectors in B. Okay, say there are M. Okay, M many vectors in B. Okay, because it is finite. Okay, because it is finite, I can define this M to be the number of vectors. Okay, say M is a number of vectors. Number of vectors in B. Okay, very good. Then what? Then we can make use of this hint. Okay, so if V is a vector space with a basis consisting of n vectors, okay, so now we have V, okay, and B is the basis of V. This B contains m number of vectors. Okay, so what does it mean? Then, okay, this means by using the hint, okay, any set of vectors, okay, any set of vectors in V, okay, consisting more than n vectors means what? Now we have m vectors, okay, so more than m vectors, okay, is linearly dependent. Okay, oops. Okay, so any set, okay, of vectors in V consisting more than m vectors, in this case these vectors are just functions, is linearly dependent. Okay, then what is wrong with this? What is wrong with this? Okay. From part 1, I mean from part A, okay, from part A, okay, we know that, okay, from part A, what we know, for any positive integer n, we can always find n linearly independent vectors in V, okay. So if the integer, okay, is m plus 1, we can also find m plus 1 linearly independent vectors in V, okay. We can find, okay, we can find, okay, m plus 1 linearly independent, okay, vectors in V, okay, which is a contradiction here, because here we say that any set of vectors in V consisting more than m plus 1 vectors must be linearly dependent. But from part A, which is the thing that we proved, we know that we can always find m plus 1 linearly independent vectors in V. Okay, so we have found that this is a contradiction. Okay, so this is false. Okay, this is false. So V is not finite dimensional. Okay, okay, it means that V is infinite dimensional. Okay, done. Okay, I hope it is clear.